Hello everyone, in this video we are going to be talking about averages. So this is a new concept. Let's get started immediately. I'm first going to read you the definition of what the average is meant to do, basically, and then we're going to talk about that. The average of a data set is meant to show a value that is representative of the entire set. Okay, now there's a lot of words in that you might not recognize, so let's talk about it. First of all, we're going to talk about the word representative. Let's describe what that is. A representative of a group, when we're talking about people, for example, is someone who speaks for the group, speaks for the group's behalf. It speaks on the group's behalf. It's like, imagine like a class president, right? So you elect a class president to speak for you. So, for example, let's say you want to say something as a class to the principal. The entire class isn't going to storm into the principal's office and start yelling like 30 people all at once. No, one person, the class president, is going to go and uh, tell the principal whatever it is that the class wants to say. And that's the reason why we say that a representative should best show the values of the entire set, in this case, the class, right? So let's say you have a problem that you want to, as a class, go to the playground more often than you do, right? And let's say that out of the 17 of you, let's say that 15 of you agree on that you want to go to the playground more often, right? Now, it would make sense to elect a representative who agrees with you on that, who wants you to go into the playground more. It would not make sense to elect someone who thinks that, oh, we should go to the basketball court more often, because that opinion doesn't represent your class in the best way, because they'd go to the principal and they'd say something different than what the class wants. So when we are trying to find the average, we want a number that is the most representative, that is the best representative of a data set. Now, what is a data set? This is a data set. This is an example of a data set. So here we have 10 people, right? I haven't given them names because that's not necessary right now. And here we can see the amount of money that they make every month. So their salaries, basically, their monthly salaries. This is a data set. And let's say we want a rough idea, a general idea of how much money these people make, right? I don't want to know, let's say, because imagine that this is not just 10 people. Imagine that this is 100,000 people, right? Or 10 million people. And you want to know about how much money they make. Now, you're not going to look at each of these numbers one by one, right? And even if you did, that's too many numbers. You wouldn't get a good idea, right? What you want is a number that is a representative of this group of numbers of this data set, right? That's what the average is. It's a number that is going to give you a rough idea of about how much these numbers are, right? So here you can see this person makes 1,000, this person makes 800, this person makes 300, this person makes 5,000, 900, 850, 700, 700, 400, and 800. Now, we do not just pick a number out of these and say, okay, this much, because then we could say, okay, these people make about 5,000 euros. That's not a good representative of this group of numbers, right? Because you can see here that everyone else makes less than that. Also, we shouldn't say that these people make about 300 euros, because no, everybody else makes more than that. We want a number that most accurately as possible represents the entire group. So, let's say we ask the question about how much money do these people make? To answer that, whoever gave us the data set would need to figure out the average of this data set and then tell us the answer by telling us each person earns about whatever the average is, that many euros, right? They do that with a very specific way. They add up all the money that these people make. So 1,800 and 300 and 5,000, all the money they make, and then they divide it by the number of people. There's a little mistake here. And then dividing by the number of people. And then dividing whatever it is that you find, that's not a mistake then. So whatever it is that you find from this addition up here by the number of people. Again, you add all the money together, right? And then whatever it is you find, you divide it by how many people there are. So here we're going to do 1,000 plus 800 plus 300 plus 5,000 plus 900 plus 850 plus 700 plus 700 plus 400 plus 800. And then whatever we find, we're going to divide it by 10. This addition gives me 11,450. And divided by 10, we get 1,145. So we could say that each person earns about 1,145 euros. Now, you'll notice that here I've written about with capital letters. Why have I done that? Because that value that we just said is the most representative of the entire set, but it is not exact. So, as you can see, obviously, this person makes nowhere near 1,145 euros, and neither does this person. But the rest of them are a lot closer than that. Well, this person is pretty far off too. But the rest of them are pretty close to that. This number, 1,145, gives us the best idea of about how much money they make. All right? This concept can be used for many different things. So let's say that we have a teacher here who wants to figure out whether or not his class as a whole, his entire class, whether they did well on a test or not, right? So here you can see their scores on this bar chart, and I'm going to explain real quick what the bar chart is. Each bar is a representative of the student's score, so it rises to the specific height of the student's score. So, for example, Alice, since her bar reaches 100, that means that she scored 100 on the test. Nick, his bar rises to 90, so his score was 90 on the test. Mike also got a 90 on the test. John over here only reached 20, so he got a 20 on this test. Kate reached 100, so she also got 100. Monica reached 70. Adam reached 90. And Christine reached 80. So these are the scores, for example, of the students of the class. And the teacher wants to figure out, did they do well? Well, in that case, he would need to find the average of the scores. And to find the average, as we said, he would have to add up all of their scores. So he would have to do 100 plus 90 plus 90 plus 20 plus 100 plus 70 plus 90 plus 80. And then whatever he finds, he's going to need to divide that by the number of students, which in this case is 4, 5, 8. When I add all of this together, 100 and 90 and 90 and 20 and 100. Okay, let's actually do this. 190 is going to give me 190. Plus 90 is going to give me 280. Plus 20 is going to give me 300. Plus 100 is going to give me 400. Plus 70 is going to give me 470. Plus 90 is going to give me 560. Plus 80 is going to give me 640. Yeah. So this is equal to 640 over 8. All right, now we can do 640 divided by 8. And if you do that division, what you get is 8. So that's the average score of the class, which is pretty good. The teacher could say, okay, well, the class did pretty well overall, so, I don't need to spend extra time on this subject. Maybe John here had a bit of a hard time. Maybe he missed some days at school. Maybe he was a little sick or something. I'll spend some extra time with him and help him figure it out. But the class overall did pretty well, so I don't need to spend more time teaching this subject. So here, for example, in this example that we did, 80 is the best representative of this data set, right? This is a data set again. Students, their scores, data set. The best representative was 80, so that's the average. All right. In the third example, we have here the temperatures of the temperatures of each day of the past week, let's say. And let's say that someone asks us, was it hot last week? Well, first of all, we would have to define what is hot. And they could answer above 25 degrees. So the question becomes, was the average temperature last week above or below 25 degrees, right? So here we would have to find the average of these temperatures by adding all these numbers up, 25 and 26 and 23 and so on. So let's do that. 25 plus 26 plus 23 plus 24 plus 25 plus 26 plus 26. And we would divide that by the number of days. So in this case, 7. Come on. All right, now by adding all of this, what do we get? All right, let's figure this out. I'll close this for a bit. 25 and 26 gives me 51. And if you want to do these additions vertically on a piece of paper to make sure, if you have a bit of a hard time following along, you can do that. You can pause the video and do that at any time. So then 51 plus 23 is going to give me 74. And then 74 and 24 is going to give me 98. And 98 and 25 is going to give me 123. 123 and 26 is going to give me 149. And then 149 plus 26 is going to give me 175. over 7. So 175 divided by 7. And if we do that division, what we will find is that 175 divided by 7 makes 25. Right? Yep, 25. So here we can say that the average temperature was 25 degrees. So was it hot? Well, it wasn't above 25 degrees. So here I might answer no. It wasn't above 25 degrees. It was exactly 25. And so that's how we work with averages. Again, their general purpose. I'm going to state their general purpose one more time. Their general purpose. You have a huge set of numbers. So let's say 10 million numbers, right? And these numbers show you, for example, how much money each person in the country makes. You can't look at each one number at a time. What you want is one number, one single number, that gives you a pretty good idea of the entire set, of the values that are in the entire set. You might think, like in the problem that we showed before, okay, but if we say here, for example, that the people make 1,145 euros, we're not, this person who's making 300 and this person who's making 400, they're not really represented. Neither is this person who's making 5,000. He's slipping by us. So yes, that's true, but this, the average, is only one of our tools. We have many for understanding large sets of numbers. Right now, we're only going to introduce the average, but just know that there are many, many tools that we use to understand large groups of numbers. So that will be all for today. I will see you again in tomorrow's video. Bye.